Okay. Hey, what's up, guys? I'm Xinqi, and welcome to this week's Antrea live show.
Yay, Xinqi, it's your first show.
Okay. On this channel, we've got weekly live show talking about the latest update on Antrea CNI. But this channel is not just about Antrea. We invited Kubernetes networking expert from VMware every week to share their knowledge with us, and also, I'm sure that you will learn a lot about the Kubernetes networking as well as the VMware's product like Antrea, AVI, Tanzu by watching our videos. So,
And
for
Yang just
example,
showed up too. Yang and Antonin okay, cool, great.
yeah. For example, last week Zach shared an awesome tool to visualize the service availability in Kubernetes cluster using tables. So go check out that video if you're interested in that, and you can find that in our channel. So, if you are new here and like this kind of content, consider liking our videos and subscribing the channel. Okay, let's see who is joining us today. Everyone say hi in the contact in the comments so I can know you're here.
We
Hi,
see
Zach.
Zach's here with his little kitten robot thing.
Yeah, Zach is here. And yeah, Jay just shared the link to the Kubernetes service validator in the comments. And we have Yang join us today from the Antrea team, and also we have new friends, and Anthony. So, Anthony, would you like to give us a self-introduction about yourself?
Yeah, so my name is Antonin. I'm one of the maintainers for Project Antrea. I've been working on it since we open sourced it a while back, more than 2 years ago now. And yeah, I've also been like helping the AVI team actually integrate the AVI Kubernetes operator with Antrea using a feature called nodeportlocal. So I hope we get to talk about this, and I'm happy to take questions on that as well.
Okay, thank you. And oh, I see Amim is here. Hi, Amim. And okay, so let's get started. First, let's invite Yang to give us a short update on what's going on with Antrea.
Yeah, I got an invitation, but I'm not 100% sure that I'm the one that should be introducing what's going on in 1.5, because I'm just working with regard to a fraction of the features there. But I've put up the notes there. So essentially, Antrea 1.5 was released last week, and we have tons of new features packed with this new release. Most notable ones include the multi-cluster functionalities. That's something that we have been working on throughout the last release, and then now it's part of the open source upstream Antrea. And I don't know if in the Antrea live show before, you guys have showcased what multi-cluster functionalities can do. Essentially, we are sort of like implementing a Kubernetes upstream multi-cluster APIs, where we as a Antrea as a CNI can manage a lot of clusters together, so that one service deployed in a single in some cluster can actually be exported to the other cluster, where they can consume the service directly. If those clusters are unioned logically together through a concept called cluster set. And there's also something really exciting we're developing in that regard, which is some sort of like policy enforcements across multiple clusters. And that's not part of the 1.5 release, but we're gradually trying to add more policy related work in the multi-cluster space. So that's something to watch out for in probably 1.6 or 1.7. So stay tuned on that. And on top of that, as I listed out, we also have multicast support and a lot of Antrea IPAM functionalities that we introduce. So essentially, we have an IP pool specification for Antrea, And then, for the pod and deployments, now you can sort of have an annotation to assign IPs from a predetermined pool, rather than just have the pod just have a random IP generated from the namespace either. So that gives you a little bit more control in terms of the IPAM of the cluster. So those are some of the really cool features that I must admit I'm no really expert on, because I'm more focused on the policy side of things. And the policy side of things, we don't have a huge bunch of features shipping out in 1.5, but there will be a lot of features shipping out in 1.6. So
I see Bernard join, and he had some. You were talking about IPAM, and I know he had some questions about Calico and Antrea's stuff. And with Antonin and you both here, it's a good time to ask that question. But go ahead, Antonin. Sorry, I interrupted you.
Well, I guess yeah, there is. It's interesting because I was gonna rebound on Multicast actually and say that it's not something that CNIs out there have typically been prioritizing. Sorry, and that's not something you have in Calico, I think, for example. And obviously, it's brand new in Antrea, and that's definitely a feature that's been driven by like user requests, right? You have a lot of like applications when it comes to video broadcast and video processing, where people have been asking about the ability to multicast traffic between pods in the cluster network, but also bring multicast traffic into the cluster network. So if you have like an external multicast source and you have like multiple pods who want to subscribe to that a video stream, for example, that's kind of like the feature we've been working on and the support we have now in this release with Antrea. So I think multicast brand new feature, but also something that's not really commonly found among CNIs today.
Can you tell us, for those of us that aren't deep in this whole multicast versus unicast thing, like what the consequences of that is? Like you said video, like where else do people use multicast?
Well, I'm not the expert there, but I would say video is definitely and people doing broadcast is definitely kind of like the main use case that's been driving multicast support for us. I can't think of anything else off the top of my head so far. Maybe other people will have insights, but yeah, that's a use case we've been focusing on. Obviously, the fact that video has been like kind of like the driving use case doesn't mean that that's all we support, right? Obviously, multicast is at the IP layer, and that's like completely agnostic of the kind of like traffic you're using multicast to transport. But I think, yeah, video is a great example because you have one source generating a video stream, and you have like multiple, in our case, pods that want to subscribe to that stream. Multicast is how you can achieve that by having like kind of like the source and everything as if it was like one connection, right? And then the network taking care of distributing that network traffic to multiple destinations.
Okay, cool.
Okay. I think we have like audience questions about the Calico versus Antrea.
Yeah, Bernard, do you want to sort of give us the question that you had? Looks like you're on mute, Bernard, or your mic isn't up. But in general, maybe you can start doing a mic check, and then meanwhile, Antonin, you can just give us the, or Yang, you can tell us.
Sure. So it looks like I'm coming the 1 week where we get the difficult questions.
Yeah.
So yeah, I mean, it's a question that comes up pretty often, right? Because that's kind of like a space. CNI is a space that's interesting because you have a lot of quote unquote competitors, right? You have a lot of choice in that space. Just because it's not something that Kubernetes is going to give you out of the box. So you have all those people coming up with their own solution. And I think the big differences between Antrea and Calico, I think the first one would be our data plane choice, right? And that's something that Jay, you were bringing up also before the show. So we're using Open vSwitch, and there are two reasons for that. I think the first one is because obviously Antrea is a project that was originated by VMware engineering, and so we have a lot of Open vSwitch expertise at VMware with like OVS maintainers, and obviously OVS was started by a company called Nicira, which was acquired by VMware in 2012, I think. And I think the second reason would be the portability of Open vSwitch, right? We really wanted to build a CNI from the get-go that would run on both Linux and Windows. And I think, Jay, you know something about that. And so OVS was a good choice, because if you don't go with if you go with like kind of like native Linux networking, then you have to kind of like build everything from scratch when you go over to Windows, and maybe some features are not available on Windows. I think with OVS we kind of have that layer that's portable across multiple operating systems, and at least you can get like a similar feel to how networking works on both platforms, even though you still have differences, obviously. And interestingly, now eBPF is going to be supported on Windows as well, right? There's a lot of ongoing work on that, so maybe there's going to be a similar story and similar experience with eBPF. I don't remember if they quite have the feature set required to support Calico, for example, on Windows using the eBPF data plane. I think there's an issue open somewhere, but I'm sure they're going to get there in 2022. And apart from that story, right, you have everything that correspond to the fact that Antrea is mostly driven by VMware engineers today, even though, of course, it's a CNCF project. So if you're a VMware customer using other VMware products, you can get like a whole bunch of integration with Antrea. And I'm sure we're going to talk about AVI. Wasn't there an episode on NSXT integration as well, or maybe in the future? But basically, you get those integrations when you use Antrea, because Antrea is developed mainly by VMware, so that's going to be a focus of development.
Cool. So Bernard, I don't know if you ever got your mic working or not, but
can you hear me?
Yes, now we can hear you.
Okay.
Was that a good enough answer, or do you want more?
Well, I caught me 75% of it because I was spending 25% of it going. This YouTube shows my earbuds as being the thing, but then I said, okay, well, let me pull down on the pull down menu where it listed them again along with other options. I clicked on it, and then it started working. So I don't really understand a system that basically displays the option that you want, but doesn't actually use it. Anyway, I'm here now. A little frustrating. I guess I had a specific question about Antrea versus Calico and Open vSwitch. And if I can I share my screen?
Yeah, of
possible?
course. Yeah, please go ahead. You can click the share button at the end. So, but maybe if you're first time using the StreamYard, you need to change the security
settings. Find the thing I wanted to show you.
Okay.
This is from a presentation. Can you see that at all?
Looks like we don't see it.
Yeah, we can't see that.
Maybe, why don't we do this? Why don't you see if you can get that running? And since the show's going, maybe meanwhile, Xinqi can start some of her AVI stuff, and we can take a break and switch over.
Oh my God.
Something bad's happening.
Uh-oh, what happened?
I mean, well, I'm going to try it again.
Okay, cool. Per, where are you from? Where'd you come from? I forgot. Are you in California? Per Peterson is here. Our old friend he's friends with the other Per from Column Networks.
Okay.
I give up.
Yeah, I think we better if we just move on with the show, if that's okay, Bernard. And
yeah. I mean, maybe I can send you. I just wanted to show a screenshot from a presentation you gave that displayed Antrea and Calico, and I had a specific question around.
I think I know what you're talking about. I can pull it up, but let's move on anyways because Xinqi's got a
Okay.
lot of stuff, and then we'll come back to it.
I'll stick it into Slack to
Okay.
this channel as well.
Go ahead, Xinqi. Keep moving. Yeah, great.
Okay. So today I invite Bhushan Pai, my friends from AVI team at VMware, to tell us a little bit about AVI load balancing. Welcome, Bhushan.
Hey, Xinqi. Hi, everyone. My name is Bhushan Pai. I'm a senior technical product manager with the AVI team out here in VMware. So AVI was the old name where before we got acquired by VMware. We were a small startup. And now it's called VMware NSX Advanced Load Balancer. It's quite a mouthful, but yeah. And Xinqi, can I share my screen? Maybe I'll start with
There we go.
Yep.
Yeah, we can see
So-
your screen now.
Yeah. So today we are going to see what enterprises or customers that we have seen think about NSX, about Kubernetes Ingress and what they expect out of it, and how Avi solves their problems and provides a consolidated solution. So basically, whenever you have your application running on Kubernetes, right, it's not just the cluster and the application you are managing. There needs to be traffic management, cert management, tying this up all into CI/CD. There is security around your application traffic, and there needs to be observability into your application as well as your infrastructure. And sometimes all of these tasks are done by different teams in larger enterprise organizations, which makes things a bit difficult the way it is traditionally deployed. So when we look at a traditional deployment of Kubernetes ingress and load balancing, it's deployed something like this. There is a ingress controller within your cluster, which obviously is multiple pods on multiple nodes. So it also needs an external layer 4 load balancing. And in addition to that, for security, you might need external WAF. That might be an external Palo Alto or some other firewall running outside your cluster, managed separately. For north-south traffic, you might have external DNS, and many times you have even seen people manually adding an A record every time a new service comes up. So all of these things is very cumbersome. And also for external routable IP addresses for load balancers, we can also have an external IPAM. Then again, for DR purposes, if you replicate the same across multiple clusters, you also need an external GSLB kind of a solution to tie this all together. So all of these multiple discrete solutions have their own way of configuring their own dashboards. So they lack end-to-end observability and makes operationalizing this difficult in the large scale. So this kind of a setup does work in a small organization or in a lab environment, but what we have seen is your business owners want a quick way to deploy apps and get going. They want a platform which will give them application availability, security, observability, and simplify their operations across multiple clouds. There are many customers that are deploying across on-prem as well as some public cloud, maybe AWS, Azure, or even VMware's cloud offerings like VMC, etc. And that's what Avi brings to the market. So Avi gives a single consolidated solution which does everything from load balancing on layer 4, ingress on layer 7, web application firewalling, GSLB, integrated DNS and IPAM, and it also gives end-to-end observability for each and every application in your cluster. And all of these can be configured in a cloud-native way, right, from your CI/CD pipeline using your Kubernetes specs or some CRDs and things like that. Yep. So before moving ahead into the actual technical details, just an overview of what Avi's architecture looks like.
Can I ask a really dumb question?
Yeah, sure.
Like, what's the so you've got Avi and you run Avi on Amazon and then you run it on Google and you run it on VMware or whatever. Like,
Yeah.
So what if I don't have any of that stuff? Do I have to have like a proprietary cloud technology to run Avi on, or is there like a bare metal way I can run it too?
That's what I was getting actually. So it's a completely software product, right? So you can actually run it on any kind of environment. You can run it on a x84 hardware and use it as a bare metal product. On VMware, OpenStack kind of environment, it runs as a VM. On public clouds also, if it's AWS, it will run as a AWS instance. On Azure also VM out there. So, and we are available on all the public cloud.
Okay, so you can do public cloud magic stuff with Avi, but if you don't have that, there's some way to run it like locally. Okay.
Yeah. So the both Avi controller.
Can it run fully containerized, or do I need a VM?
You need a VM. We
VM, okay.
used to have a container form factor earlier, but because of challenges and basically we made a design choice to terminate that and deprecate that and be only as a VM.
Cool.
Bhushan?
Yeah.
Many organizations use Envoy as their sort of ingress controller.
Yes.
Within Kubernetes clusters. I mean, they use it other places too, but within Kubernetes clusters. Does this imply then that you would use Avi in place of Envoy?
Yes. Yep.
To replace it? Okay.
Yeah, say you are using something like a Contour or a Nginx ingress. You with Avi, you do not need that. The same Avi service engine. So these are the data plane engines of Avi are called service engines. Those perform both layer 7 and layer 4 load balancing for you, even though they are sitting outside the cluster. So you do not need another ingress controller within the cluster at all.
And will you discuss the relationship between Avi and Istio or comparison and whatever?
Yes, not as a comparison. Actually, currently Avi only supports a layer as running as layer 4 load balancer in front of Istio ingress gateway. We are working on more deeper integration into Istio platform, effectively replacing the Envoy gateway, the Envoy proxy running as the gateway, basically.
So when you say in front of, does that imply the internet traffic comes to Avi first and then goes into Istio and then?
Yeah, that's
and then Istio would call back out to Avi, or would then go, because Envoy is the most common data plane tool used by Istio environments.
Yes.
Does that imply that it would go through Avi, then to Istio, and then to possibly Envoy, or would go back out to the data plane Avi?
So no matter what kind of ingress controller that is, right? Since it's scaled out on your cluster, it requires a layer 4 load balancer outside, right? So with Istio, that's what Avi supports right now. So Avi can take encrypted traffic out here and do a pass through to the ingress controllers and can get the SSL terminated out there, and then Envoy can do its thing and manage the Istio network inside. Does that answer your question?
I think he's asking the general. Yeah, it sounds like the general question of where's your service mesh start and your L7 stuff end. And yeah. I think that's it makes sense to me, I think.
Okay. Yeah. So
any service mesh is generally always in cluster, right? It always manages things in the cluster, but after that, you need something like Avi on the outside to do the other stuff.
And we have it on a roadmap to have this service engines to run within the cluster to replace the Envoy, basically, but only for the north-south part, not the east-west within the cluster, only for traffic coming into the cluster. Yeah.
Cool. Okay. Let's see what you got next.
So moving ahead, just wanted to before I move into how this thing works on Kubernetes, just a general architecture of Avi. Like I said, AVI primarily is a load balancer. So even without Kubernetes, you can use it with VM environments also. And unlike any other load balancer in the market today, it has a distributed architecture. What that means is there is a centralized AVI controller, which is the brains of the product. So all configurations are done on the controller itself, while the data path, the actual traffic load balancing is done by these data path engines called service engines. Being software, it can be run on any kind of environment, and the controller can manage the scale of these service engines. So you do not have to pre-provision them. Whenever a new application is created or current application requires more performance, this controller can create new service engines as and when required, and basically provision elastic load balancing for you. And as the traffic flows through these service engines, it also gathers hundreds of different metrics and analytics, so that you have a great dashboard on the controller where you can view all of these metrics and analytics for your application. And the controller internally also uses these metrics to make intelligent decisions for scale out and scale in.
So when you say controller, you mean thing that's controlling the why? When you call that a controller, you're not talking about a Kubernetes controller. You're talking about a different kind of controller.
Yeah.
That's job is to program cloud firewall rules with respect to the way you want routes being sort of pushed down into your data center, whether or not you're using Kubernetes for your applications or not.
Yeah, so to build an analogy out here, just like NSX has its NSX manager, which also runs as works as a controller. Similarly, both the management plane and the control plane for AVI load balancing is on the controller. So you can configure policies, you can configure your virtual services, pools, any kind of a load balancing algorithms, etc., out here on the controller, and that will get pushed to these service engines. And the service engines does the actual magic of doing the load balancing.
Cool.
Right. Yep. So, like I said, both the AVI controller as well as the service engines run as regular VMs. They sit outside your cluster. So in order to integrate this with Kubernetes cluster, we have two operators. The first one is AKO, or AVI Kubernetes operator, which manages the local load balancing for the cluster. So it's a simple stateless pod running within the cluster, and it doesn't part in the data path. All it does is translates the Kubernetes objects to corresponding AVI APIs and configures them on the controller. The controller in turn places the whips for those virtual services on the service engine, and the service engine then do the load balancing. So AKO is basically just a translator from Kubernetes spec to AVI APIs. Similarly, we also have AMKO for multi-cluster operations. So if you have the same application deployed across multiple clusters for DR or HA purposes, you can use AMKO, which syncs those across multiple clusters and configures GSLB, or global server load balancing, on AVI. And we'll see both of these in the demo, which will make it a bit more clear. Okay, yep. So going ahead with the deployment. Now, speaking of Tanzu, AVI, being a VMware product, has a really good integration with Tanzu, and this AKO component that we were talking about is automated out there. So when you are creating a new Tanzu cluster, the AKO automatically gets deployed and connects back to the AVI controller, and your load balancing is pre-provisioned for you, pre-configured for you. But just to understand how these things work, we'll take a look at if you are deploying this on a general upstream Kubernetes cluster, how it goes. So day zero, you have your AVI controller installed. You have to configure the infrastructure cloud. The infrastructure cloud gives you the AVI controller a way to sync all the objects in your infrastructure. For example, if you are running your cluster on vCenter, you configure a vCenter cloud on the controller, and it will sync all your host clusters or your port groups so that it can automatically provision your service engines and give you the load balancing. Similarly, if it's running on AWS, you configure an AWS cloud, and it will sync all your VPCs, your auto-scaling groups, your networks, etc.
This is all AVI controller that you're talking about right now, right? Still.
Yeah, this is all about AVI controller.
Yeah.
We haven't yet deployed the AKO.
You should call this slide AVI controller.
It's more about Okay.
I'm just teasing you, man.
Yeah, that's fine. Yeah. So the next step, once the AVI controller is up and running, the controller still doesn't know anything about Kubernetes running in your environment, right? So you install AKO. This can be easily run using a Helm install command with some bootstrap parameters given to it, and it will connect to, subscribe to the events on Kubernetes, as well as connect back to the AVI controller. And with that, your cluster is ready to take new applications and for AVI to provision load balancing for it. Similarly, if you have multiple such clusters, each of them can have AKO running on them, but they can home back to the same AVI controller, and they can either share the same pool of service engines or can have dedicated service engine resources allocated to each cluster equal to. So it depends on how we want to design it.
And does the AKO download the relevant policies for its cluster?
No,
so that, the next time it gets called, it goes, okay, it looks internally and goes, oh, I should send this way, or I shouldn't send this way?
Yeah, so AKO does not sit in path of the traffic at all. It's only management plane of it. So it's only configuring things on the controller. So say you have a ingress configured, and you have rules in it saying that for this this path, send it to that so-and-so service in the backend. So it will configure that on the AVI controller, and the actual policy enforcement is done on the service engine itself. When the client sends the traffic, the service engine decides based on the host header or the path where to send it. So yep. So that's what I was going to show. So whenever a new service is created, so AKO supports both Kubernetes as well as OpenShift. So it can be either ingress or a route for L7, as well as service type LB for L4. It's created. AKO automatically gets notified because it subscribes to the events, or it also does poll every so often, so that just in case it has missed something, it can act on it, basically. And whenever a new service is created, it translates that to the corresponding virtual service on AVI, and AVI runs its internal DNS, so DNS and IPAM. So it fetches an IP address for the VIP and publishes the FQDN to its internal DNS and places the VIP on the service engine. Yep. And the next step is to see how the actual traffic flows. But before we go there, let's start with the demo to make things a bit more clear, and we'll come back to this. And yeah, please feel free to ask any questions in between. So yeah, for the demo,
it might be a little newer to Kubernetes. In general, the kubectl expose command, you can expose something as a load balancer service, or as a node port service, or as an ingress service, easily just using that one command. And then the problem always winds up being like, okay, you expose something as a load balancer, who the hell's going to make that external IP, right? So AVI does that, but it also, if you expose something as like an, expose it, if you create an ingress, if you do kubectl create ingress, then you have an ingress controller that's watching that resource too. So AVI does both of those. Yeah,
instead of an ingress controller, the AKO.
This is always confusing, because people get like, you'll get a GCE cluster. It used to be, I don't know if they solved this now, but like by default, you'll get a cluster in GKE or whatever, and you'll create an ingress and nothing will happen. because there wasn't a default ingress controller. So
balancer.
this is like always confusing for people that are new to Kubernetes.
Yeah.
So AKO sits in the cluster per node and reads what gets put in by Kubernetes, and then it uploads that to the controller so that the controller knows what the policies are for the overall connectivity.
Yeah,
and then to put it down to the data plane, AVI data plane objects.
Yes, the service engines. That's right. Only thing is that there is only one AKO running for the whole cluster. It's not per node required. And anyways, it's a stateless pod, so even if it dies, it restarts and takes over very fast.
What was the? I might have been distracted. What is the underlying? Like Contour uses Envoy as the underlying data plane thing.
Yeah.
What is the underlying generic thing that allows AVI to do the thing where you connect the IP to the actual service IP that's inside the cluster?
So the actual load data path is Envoy in case of Contour. Out here, it's the AVI service engines. The confusion is because the service engines are sitting outside the cluster, right? And in order to reach the pods from outside the cluster, AVI does some routing magic, which we can talk about if you want. But yeah,
we don't have to talk about it. But what's the buzzword for the magic? Is it like you just do some fancy Linux thing, like you just have something that runs as root that can set up routing rules on a Linux node, or is it?
Yeah. So let me do one thing. I'll open up a few slides and walk through it. It will make it a bit more clear. Basically, AKO and AVI automatically manages some routing rules in order to let the service engines directly connect to the backend pods. And that's where even the nodeportlocal in Antrea that we were talking about at the beginning of this Tanzu Live also comes in.
Okay, cool.
Okay. Yeah, so let's get started with the demo, and we'll touch on the routing part also. So, for the demo, what I have is a AVI controller and a TKG cluster installed on my vCenter environment. And this is the AVI controller UI. Right now, I only have a DNS virtual service running, which acts as an authoritative DNS server for all the applications that we create on Kubernetes side. Like I said, the day zero operation is to install this AVI controller VM, log into it, and configure your infrastructure cloud. So what Xinqi is going to talk about next, this is a kind of a prerequisite to that too. So you need to have the AVI controller up and running, and basically give it the username password for your vCenter environment, configure your IPAM and DNS profiles in here. Select which data center within the vCenter, what's your networking management network looks like, and kind of things. I won't go too deep into what that is, but basically this allows the controller to discover everything on the vCenter side. For example, it will discover all the networks that there are on the vCenter environment. And it automatically create service engines whenever required on those networks. So right now we do not have any applications, but we have a Kubernetes cluster already running. And like I said, since this is a TKG cluster, it already has a AKO running on it. In case of your regular Kubernetes, you can easily install it using Helm also. So let's go ahead and create our first application. And I'm going to do really simple application. Let's take a look at what we just applied. Yeah, so it's just a simple deployment spec running 2 replicas of this demo server, and I'm exposing it using a load balancer type service. So it's of type load balancer. And as you see out here, AKO automatically syncs that service getting created, and it creates the corresponding virtual service on AVI. So let's go to a different view, which will give us more details. And as you see, for this load balancer type service, we have an IP address automatically assigned from the IPAM. It also has a domain name automatically created and published to the to the DNS. So any client browsing to this will automatically will resolve to this IP address. And right now it's showing red because this is the first application we created. There were no service engines running, so it's creating one. So, and if you take a look at the vCenter side, it's actually creating those service engine VMs. It will take around 1 more minute for it to come up.
Wait, so why are these VMs coming? Like, isn't AVI already installed on this cluster? Why do you need a VM just because you made a?
Yeah,
You
so
made a new.
there are multiple VMs out here, right? The controller itself is a VM. Then the service engines are
Yep.
the actual data path of VMs again.
But you don't make a new VM per service, so why is it making a new VM right now?
Because AVI creates them only when required. Since there were no services earlier, there were no service engines.
Okay, and then each VM can do 50 load balancers, and then
each service engine can do around 500 virtual services on it. So the next time we create a new service, it won't create a new VM unless it's required. Yeah,
that was a good guess, right? I was only off by like 490 services
by order of magnitude. But yeah, so that's how it works. So this is the first service we created. It's trying to create a new service engine. So it will automatically create the VMs. It will figure out which network it needs to connect to because it discovered all the networks and the subnets in it. So it will connect to the VIP network as well as the network where your cluster is running. And then your virtual service should go green in some time.
Cool.
So yeah, while we are waiting for this, let's talk about the way the traffic works in this in this scenario. So like we saw, the VIP is also already published to the DNS. So whenever a client makes browses to that FQDN, the DNS resolves it to the correct VIP IP address. The client sends the traffic to the VIP, and that way it gets to the service engine. Now this VIP can be placed active on multiple service engines at the same time. So if you are running some massive application which needs a massive throughput, VIPs can be scaled and multiple number of times horizontally to give that kind of a performance. So it comes to one of the service engines, and from the service engine, it will get directed load balanced to one of the pods running within your cluster.
Wait, how does it? If I make it L7, who decides what the VIP is for the L7 rule?
It's automatically pulled from the IPAM. So you give IP address.
I generally get a new VIP for every L7 rule?
No. So for layer 4 load balancer type services, you get dedicated VIPs. For layer 7, we do something called sharding. So in AKO, you specify how many shards you want. That many number of VIPs will get created, and we'll create a L7 application in a while. We just created a layer 4 service now. So say you want 4 VIPs. So we will maximum create 4 VIPs, and your ingresses will get mapped over those VIPs based on their host names.
Okay, cool.
Yeah. So right as you see, the service engine is connected back, and if you go to the dashboard,
is this stuff like if I'm on Amazon, does this do Route 53 stuff for me?
Yes.
Like, can I do that? Oh, that's cool.
It does. So I forgot to show that. So in the day zero operation, we configured a vCenter cloud, right? Similarly, we have other ecosystems that we support. So if you go to AWS cloud, you can just.
So if you buy AVI, you never have to use Route 53 ever again for the rest of your life. You never have to go click stuff and then.
Yeah, so actually you can do that. You can use our internal DNS profile so that the DNS virtual service can do that, or you can even use Route 53 so that AVI publishes this to Route 53 too.
You'll just directly do it. Okay.
Yeah, both ways are possible.
Bernard, how are you doing over there? I know we've like done a bunch of other crazy stuff since you asked your first question. But you got anything else for us?
You showed the slide of the data path.
Yeah.
I think could you bring that back up?
Yep.
That was so a client is something outside. It's like from like somebody on a PC somewhere says, I want to go get to this. It comes in, it hits the data plane executable, right? So to the AVI VIP via DNS.
Yep.
Okay, the client sends the request to the VIP, and that's a IP address that's assigned to this data plane object, and the data plane object is the first thing it hits.
Yeah, that's right.
Data plane. I mean, it's data plane executable.
Yeah, the service engine. That's what it's called.
The service engine chooses a particular pod to send the request to.
Yeah, that's right.
Goes down to this pod and goes down to this node and hits this pod.
Yeah.
When you say you choose a backend pod, though, you actually are hitting an internal cluster IP service, and the cluster IP is choosing the pod.
Not service. So if you see out here, right, the virtual service pool, it has individual pod IP addresses in it.
Oh, so you skip kubeproxy entirely?
Yes, we do.
And you skip Antrea proxy too, then, huh?
Yeah. So.
Yeah, and if the pods are not directly routable from the AVI service engine, that's where the nodeportlocal feature comes in, Jay. Kind of like, yeah, it's a kind of like replacement to if the pods are directly routable, right? The AVI can just set the destination address to the pod's IP directly. But if the pods are not routable in that network, only the nodes are, maybe because you're using an overlay with Antrea in Tanzu, for example, then you need to send traffic to the node to a specific port that Antrea working with AVI have allocated, and then we do port forwarding so that it actually gets to the pod. So we still skip kubeproxy and Antrea proxy, so you have a single load balancing step which is done by AVI, which was the whole point of that feature.
Yeah.
But you need you need collaboration between AVI and Antrea in that case, because the pods are not directly routable because you may be using an overlay network.
So that's a good segue into these slides. So AVI supports 3 different modes: cluster IP mode, nodeport mode, and nodeportlocal with Antrea. So for the demo which we are doing right now, it was using cluster IP mode, in which what happens is each node has some pod CIDR mapped to it, right? So say this node has 2./24 mapped to it. The next one node can have 10./24 mapped to it. And AKO reads that from your Kubernetes side and configures corresponding static routes on the SE through the AVI controller. Basically, it runs the API to AVI controller, and AVI controller configures these static routes. So whenever traffic comes to the web, to the service engine, and say it wants to load balance to a pod with IP address 10.100, it will use this static route table to determine which node it's running on. So it will send the traffic with the source IP of the interface, service engine interface, the destination IP of the pod, but the source MAC is of the service engine interface, and the destination MAC is of that of the node, not the pod. So on L2, the packet will flow to the node, and within the node, the CNI takes care of routing it to the actual pod. So that's how it reaches the pod.
And so the routes to these different pods are inside the data plane object.
Yes, that's right. And these
so
are
and it downloads them. How does it get them? Does it download them from the controller, or?
Yeah, the controller programs them on the. So this is the flow is always from AKO to the controller to this service engine object. So AKO programs. AKO learns about these routes and programs them on the AVI controller, and the AVI controller programs them on the service engines wherever the application is placed, basically. So on the AVI controller side, if you see out here in our setup, Under routing, we have two nodes on the TKG side, and we have the routes for them here, which will be pushed to the service engines. It's a bit difficult to understand, but yeah, we also have other modes to do the same thing. So in some cases, doing this kind of a routing is not possible. For example, on AWS networking, it does not allow this kind of using a different MAC for a different IP address in a packet. So out there, we can also do something like nodeport mode. This is a general nodeport, in which case the service engine load balances to your nodeport service on the Kubernetes, and kubeproxy takes care of the final load balancing to the pod.
So in cluster IP mode,
Yeah.
you make your own cluster IP service that operates at the AVI level, essentially. Whereas in nodeport mode, you reuse the node port that's implemented by the Kubernetes service proxy.
Yep, that's right. So the VIP becomes the actual cluster IP, but it's actually exposed to the outside. It's not internal to the cluster. And yeah, there is the third mode is nodeport local mode. Because
what does AVI stand for? Zach wants to know what AVI stands for.
AVI is actually a Sanskrit word. It's not a acronym. So
Because my dad's name is Avinash.
yeah. So AVI stands for Rising Sun. So
he gets up at 4 a.m. every day.
Yeah. So yeah, the third mode is nodeport local mode, in which Antrea exposes every pod as a node comma port. The port can be different on every node, and there can be multiple ports on the same node also. So each pod will be exposed as a node comma port, and that's what is added to the pool. So there is no routing required. The service engine directly routes to the pod IP address. I mean the node IP address colon the port, and that way Antrea takes care of taking the packet to the correct pod in that case.
So nodeport local, Vivek is saying the real core thing of it is it allows you to move the node port out of the cluster so that it's now managed by Antrea, and now you don't have collisions. Is there another reason why you use nodeport local? Is it faster than is there other reasons why you use it, or is it just?
So from load balancing point of view, these are the actual reasons.
Thank you.
Yeah, so cluster IP is really good because it gives direct pod connectivity. So you can health monitor all the way to the pod. If the pod is down, the AVI controller knows about it, which is not possible in the nodeport mode because we are health monitoring the service, the nodeport service, not the actual pod. Persistence is also possible with cluster IP mode. Because we can persist all the way to the pod IP address, again, which is not possible.
What persist what?
Client request, basically. The client connection can be persisted all the way to the pod. AVI has multiple persistence modes, so you can persist based on the client IP address.
Wait, is that the same as Affinity, or is that different?
Yeah.
Affinity. Okay.
Yep.
Cool.
The only downside of having cluster IP is that it must be directly connected to the node. The service engine must be directly connected to the node network, your cluster network, in order to do the routing.
And when you tell AVI to make a nodeport local versus nodeport versus cluster IP, how do you add an annotation to a service?
No,
what is it? How does AVI know which one of these things to use?
It's a AKO configuration. So when your AKO is installed,
it's the same for everything. So it's a one-time deal, and everything's going to be the same. Okay.
Yes, that's right. Yeah.
So has anybody ever asked to use cluster IP for some services and node ports for other? That's not something.
No.
Okay.
I haven't got any requests like that. Yeah. So basically, out here, the service engine must be directly connected, which is not a case in nodeport because the service engine can route to the node IP. So nodeport local gives the best of both worlds, in which we do not have to connect to the node network directly, but you can still have everything like health monitor and affinity directly all the way to the pod. The only thing is it's all currently only supported with Antrea.
Okay, so this isn't like a choice thing. This is like a better to worse thing, and nodeport local is the best.
Yeah.
And is there any choice between cluster IP and nodeport, or is there a reason somebody would choose one over the other?
Many times, if customer wants something like persistence, then cluster IP is a better choice. But many times they are just regular general web applications, so which do not require that kind of a persistence, and also they are not stateful services basically. So nodeport will be a easier option. In which case you can even share the there is another thing, right? With cluster IP you need a dedicated SE group, so once a SE group is used for a cluster you cannot reuse it for another cluster. So that is also relaxed in nodeport mode. The same SE can be shared across multiple clusters also. So all of these drive the decision to go one way or the other.
So the cheapest is nodeport, and then slight optimization over that is cluster IP.
Yeah.
It's a little more expensive.
Yeah.
Compute. It's like you literally would have to pay more. You might have more
servicing.
You need more horizontal scale on your AKO plane, and then or in your controller thing.
Yeah, but we do have some licensing magic out there to reduce the cost, just in case it grows too much.
And then nodeport local is you don't need to do any extra scale because you're relying on Antrea's OVS magic for that. And then
so it does give the best of both worlds.
This is pretty cool. You worked pretty hard on this, huh? Some late nights.
Yeah, I think I have eaten up completely into Xinqi's presentation time.
We can go a little extra. We can go at a little extra today.
Okay, so let me at least show a quick ingress layer 7 service created, and then maybe I can hand it over to Xinqi. So let's quickly create that. So we created an application, but we exposed it using just regular load balancer. But an enterprise application will need SSL termination, and also we can just create a TLS ingress. Let's take a look at that too. We have a secret, and we are using that secret in our TLS terminated ingress with edge termination. And as you see, we created, like I said, we do sharding. So it created one shard and then mapped this virtual service onto it. Again, we are load balancing all the way to the pods, even though the service engine is sitting outside and doing ingress. There is no ingress controller involved in between. So on this side, again, the IP address, the FQDN, everything is automated by the IPAM and DNS, and your service is up and running. So any client browsing to this will automatically get resolved to the correct service. Yeah. So there are, if you take a look at AVI, right, we have a lot of configuration options of knobs in here. Both on the virtual service side, we can configure policies, analytics, etc., which are not directly available through regular ingress spec. So in order to configure those, we have certain CRDs, custom resource definitions. So let's quickly do that too.
Vivek has like a really super detailed question for you.
Sure.
He always asks one really hard question every time. He's saying, can you hack around the cluster IP thing if you make sure that pod siders are not overlapping?
Yes, it is possible, but not officially supported through VMware GSS. So, yeah, it is definitely possible. If the pod CIDs do not overlap, you can use the same.
Evidently, your hack works, Vivek.
Yeah.
Vivek's idea works.
So yeah, moving ahead, I was just going to show. So we can, using the CRD, we can configure many things on both the virtual service side as well as the pool side. We have host rule CRD to configure things on the virtual service. So it says that for the ingress with this FQDN, this host name, configure all of these things. So we are changing the certificate, you're changing the SSL profile, adding a new policy, changing some WAF policies, etc. And if you take a look at the virtual service out here,
But did you make your own health check API? What's that all about?
yeah, you can also change your health checks out here too.
So it's a CRD and it implements your layer 7 health check.
Yeah, it can be either layer 7, layer 4. We have multiple health monitors available in AVI, and you can even create your own custom ones.
So target, can I add like an endpoint to that, to the health check?
So yeah, as in,
I see HTTP. Can I have it point to like a health Z? You know, like the way you would do with the regular Kubernetes health check for a service.
Maybe I'm not aware of that, but we do also support different types, right? So if you do external, you can even script it out on your own. This is more like a data plane level health checks, not liveliness probe that Kubernetes does, if that's what you're...
Yeah, I'm talking about readiness checks that you would normally do in liveness checks. But
so AKO takes care of that. Based on liveliness check, whenever Kubernetes marks the pod up, AKO takes care and adds those pods to the pool automatically. So if your liveliness check fails, it will automatically remove this endpoint from the pool out here.
Okay.
So that's taken care by AKO, but doing data plane level health checks is what the service engine does. So you can configure multiple things out here. You can change the load balancing algorithm, change the persistence, the affinity thing, which you were talking about earlier.
Okay.
Similarly, on the virtual service side, you can enable WAF, you have extra policies, custom policies applied to this. So we enabled WAF policy out here. We added some custom policies blocking embargo countries, rate limiting DDoS attackers, etc. Using the CRD. And yep.
What are the embargo countries? What's that?
It's like countries from where you think attackers mostly come in. So.
What country is that?
This is just an example. So I'm not sure what we added out here.
Okay.
Yeah, we'll have to see what the group contains. I'm not sure.
I didn't know that people did that. Weird. Okay, cool.
So yep, this was the one last thing. Sorry, Xinqi. So now that we have this application running on one site, you might have a DR site, for example. This one is running in San Francisco. I have another similar setup running in New York site, and you want to tie this up together for DR purposes. We also have AMQ running on the cluster, so it will automatically configure a GSLB service. So if any client browses to this FQDN, it will automatically be resolved to either the New York IP or the San Francisco IP, and based on whatever algorithm you have. So you can change the priorities of these. You can do different ratios between these, and the GSLB will take care of making sure if something is down, it will not resolve to that, basically.
Okay, now Xinqi's turn.
Yep. All right.
Oh, it's already like more than 1 hour, and actually I prepared for like a 20 minutes demo. so I think that we can do that next week along with the IPv6.
That's actually not a bad idea. Yeah, like we could just do another show next week, and then we could go into the IPv6 stuff. So everybody come back next week, because then we can do. That's a good idea.
Yeah, we invite the coding team to tell us more about IPv4, IPv6 supported on Tanzu, and pretty looking forward to their demo.
Cool.
Okay. So before we end this episode, so if you are new here and like this kind of content, considering subscribing the channel and share this with your friends that might be benefit from this kind of content. Okay.
Yeah, like and subscribe.
Okay, everyone. See you next Wednesday.
Cool.
Bye.
Bye.
Thanks, everybody. Say
everyone.
thanks, Xinqi.
Thanks, Bhushan.
Thanks, Bhushan.
Yeah.
Thanks, Bernard and Antonin. All right. See y'all. Antrea Live. See you next week.